2.2 Intramolecular Forces and Potential Energy. Topic overview. Covalent bonds are the bonds between two nonmetals when they share valence electrons. Covalent bonds can be polar or nonpolar, meaning that the electrons are shared unequally or equally. Covalent bonds can be single, double, triple bonds, or an average of those if there are resonance structures. Covalent bonds occur at the lowest energy state. This happens when the attraction between the nuclei is greatest for the shared electrons, but the repulsions between electrons and between the nuclei is the least. If the atoms are too close together, the nuclei will repel each other. If they are too far apart, the attraction will not be enough to hold them together. This is shown in the graphs below. Bond energy is the energy required when breaking a bond, or the energy released when a bond is formed. The magnitude is the same, but the sign is different. Larger atomic radii increase the bond length. Longer bond length decreases the bond energy. Increasing the bond order increases the bond energy, as there are more electrons involved and therefore greater coulombic attraction with a decreased bond length. Lattice energy is the amount of energy needed to separate the ions in ionic compounds. It is defined as the change in energy that takes place when gaseous ions are combined to form an ionic solid. Combining ions will release energy. Lattice energy can be represented using a modification of Coulomb's law, where the energy is proportional to the charges and inversely proportional to the distances between the nuclei. Larger charges equals more attraction, equals more energy required to separate the ions. Smaller radii equals more attraction, equals more energy required to separate the ions. In the first picture, the distances between the atoms are shown, as well as the energy absorbed or released when the bond is broken or formed. It also shows how to read the graph to determine the bond length and the bond energy. The second picture shows the difference between a shorter bond, Cl-Cl, and a longer bond, Br-Br. Complete the graph by showing the location of the curve for the II bond.